interesting. Next, we'll be calling Nathan. So Nathan, over to you. You can share your screen.
Hello, Nathan.
Hi, Dr. Hana. Yeah, also, hi, Mr. Zor, Mr. Kashyap, and Mr. Akil. Yeah, so today I'll be presenting about my COVID-19 analytics dashboard. So first, just a quick introduction. So I'm Nathan from Big Data Analytics in Temasek Polytechnic. Yeah, so we are all familiar with COVID-19. I'm sure that doesn't need any introduction at that point. Yeah, so all of us in this call, we're all from different places. So whether it's India, Dubai, New York. Yet when COVID-19 first hit, do you all remember how it felt? Like we were all trapped at home, sitting in front of our screens. Yeah, I'm sure you feel that, right? Yeah, so COVID-19 really affected us all. It's a global effect because all of us were affected in some way. And I think in 2020, East Asia Forum article actually suggested that healthcare systems, especially in developing countries, they will face significant capacity constraints because they had limited supplies, they had not enough resources, and not enough administrative capacity. And I believe that technology can play a part and have a role in solving these problems. So why is my dashboard this? Why did I choose to build a dashboard now in 2024? Because the pandemic seems to be going down, right? So a professor from UF College of Medicine says that COVID-19 may be here to stay for the next 10 years. We don't know exactly, but that's a rough estimate. And we see that happening because COVID-19 has new variants, it has new, more transmissibility. So I think that COVID-19 will be here to stay, and therefore it is still valuable to do this dashboard. So I think that having a solution that finds patterns between COVID-19's factors and symptoms is very important and will be highly beneficial to the public healthcare sector. So in tandem with this...
Sorry to...
Yes.
Sorry to interrupt, Nathan. Can you show the full screen if you are not referring to your notes? So are you referring to your notes?
Sorry, sorry, I forgot to put the full dashboard.
Okay, sure.
Okay, yeah, is this better?
Yes, that's
all right. Sorry, I forgot to change the screen. Yeah. Yeah, so in tandem with that, the project objective is to develop a dashboard that offers a good visualization of COVID-19's factors and symptoms. So in other words, what conditions are related to COVID-19 and what factors can cause it. And this understanding this can enable both stakeholders like healthcare professionals and also the public to understand how COVID-19 spreads and to enact more effective prevention measures. So in accordance to that, we actually have two countries that I've developed for. So firstly, United States. This is built in to the synthetic generator tool that I have used. So I've decided to use two states, that is California and New York. And for India, I actually managed to do a custom demographic resources for the synthetic generator. So I'm able to generate data for all states, but I've actually chosen to do two for this current project. Yeah, so I've also done some research about IPRD, and I've noticed that you have actually built much digital technology to further the greater good, especially when it comes to healthcare. And I've also noticed that recently there's been a lot of projects that you have done on COVID-19. So things like Bluetooth contact tracing and vaccination certificates. So these are things that are invaluable to us. Yeah, sure, Dr. Hana, you can attest to that. Yeah, because this is a project that you have done that probably worked on as a company.
Yep, absolutely. That's great.
Yeah, so I realized that the solution is also has other factors other than technical capability. So I noticed that most of the projects actually rely on free and open source tools. So this allows it to be powerful as well as scalable and will allow the solution to be scaled even to third world countries where there is less resources available to them. And so in accordance with this, I'm also building a project that is also COVID-19 related. So yeah, much like these projects that you have worked on. So a background on my COVID-19 analytics dashboard. So I think Sriniti and Ian have mentioned about the rough flow. So I thought that I would just condense it down into a single pipeline. So you can see how the pipeline looks like. So we start off on the left with the Cynthia data that we actually generate. So Cynthia is a synthetic generator tool. So we are able to put in whatever state, whatever modules we want. So the modules actually represent what healthcare conditions the patients will have. And so for me, I put COVID-19 together with other findings, other conditions that these COVID-19 patients may also have. So this is a synthetic tool. So even though it's based on real data, but it's actually generating fictitious data so that we don't have any privacy concerns. So after we generate the synthetic patients, we post them to the FHIR server, which is the where we store all the patient data. And then using the FHIR pipelines, we put them into Hive, where we can use Spark and PySpark to query the data. And this is where we do the ETL. So because in FHIR, a lot of the data comes in JSON format, which is very nested, very deeply nested, and it's very difficult to do analysis on it. So because of that, I use SQL to sort of flatten it down into a single level table. So much like Excel or data frame, it's just one table, row, and a column. And that makes it much easier for us to do analysis on it, and also visualization. So when we move on to superset, it is much easier for us to do visualization based on this tabular format. Then I've also done predictive analytics. So more specifically, I've actually used unsupervised clustering techniques to segment the patients. So this is not complete yet. This is still a work in progress. But the rough structure is like this. So I have a Hive database. I use PySpark to perform the k-means clustering. So PySpark will run scikit-learn, which is the Python library that allows us to perform k-means clustering. And then this is the part that's work in progress. I'm actually planning to put the k-means clustering data into Superset so that I can better visualize it in a dashboard. So I think at this point, I will switch to the Superset and we can look at the dashboard. Yeah, so this is the COVID-19 analytics dashboard. So we first start off with the number of cases. So we can see a big number chart. So this allows us to see how many cases there have been. So you can see that it's quite a big drop. So the peak was around November to January. So November 2020 to January 2021. That's roughly where the peak was. Around 700 cases per month. And then it has gone down quite a lot. So in September, where the data was last updated, there's only 42 cases, which is a huge drop, minus 77% over the previous month. So I think it's important to reiterate that this is based on synthetic data. So much of this may not reflect the exact trends in the real world. However, when we put in real world data, then that will change because this pipeline can be used with real world data. And then in the next chart, we have time to recover from COVID conditions. I think many people have experienced this. If you have gotten COVID before, you'll get cough or you get fever for some point. And then at some point, you'll lose your voice or lose your taste. It really differs from person to person. And even for the same person, many of these conditions can last for a different period of time. So this chart actually shows, for example, fever typically lasts the longest, and something like cough lasts slightly, has slightly less, so 21 days, and something like the other conditions that you see here typically last for fewer number of days. So this allows us to plan it out. Yes.
Sorry, Nathan. So just to understand the axes, so time is vertical. Is that right? Maybe you could explain the axis if you could. Yeah.
Sure. Yeah. So the time in the days to recover is actually on the vertical axis. So you can see that the ones towards the top are the findings like headache, like sore throat, fatigue. So these are the conditions that typically last about about 3 weeks in this case. So about 21 days. So these are the common findings.
Right. Okay.
And the size of the bubble actually represents how many COVID conditions were related to these findings. So you can see the big bubbles like fever is over 1,000. So there's a lot of patients with COVID-19 that actually got fever. And I think this is quite consistent with what we have experienced. A lot of people who get COVID do get fever, they do get cough, they do get loss of taste.
Yep.
Yeah. And then the x-axis is actually number of patients with that particular condition. So for example, we see that there's a lot of people with fever and cough. These are the most common findings with COVID-19.
Okay.
Yeah.
Thank you. Okay.
And then for the COVID-19 prevalence by vaccination type, so I think this is interesting. So there's a big question sometimes if you want to get a booster shot now, I mean, I assume most of us are vaccinated, but if you want to get vaccinated now, which one is the best to choose? There's quite a lot of options. And in this case, we have listed down three main ones. So Johnson & Johnson, 10.2% of people still ended up getting COVID. And we see that Moderna is actually the best. So here a lower percentage is better, because obviously if you get vaccinated, you don't want to, you hope that you will not get COVID-19. So yeah, in this case, Moderna is the lowest, very closely followed by Pfizer, and then lastly we have Johnson & Johnson. And this next chart about COVID-19 prevalence by age and vaccination is very interesting, because we grouped the patients by age. So from 10 all the way to 100. So we have grouped them, and we noticed that a trend for the younger patients. So for patients that are less than 60 years old, in other words, we see that patients that are not fully vaccinated have a much, much higher chance of getting COVID-19. So especially for young people, for young adults, that is quite true. So this is a good chart. So if the public see this, especially if you're a young person, I think it's definitely a very important thing to get vaccinated, to avoid or to reduce the chances of getting COVID-19. And you can even use this as a filter. Oh, I have no idea why this happens. But yeah, we can use this as a filter to... Wait, let me refresh the dashboard. Sometimes it has database errors for some reason. So if we can use this as a filter as well.
Okay.
Yeah, so we can filter other charts.
Very
and good. This one lists down the symptoms and conditions and the number of patients that have them. So I think we can clearly see that, fever and cough, loss of taste, these are the top few. And for COVID-19 symptoms, we also see that this same trend here. And this shows that it's a fairly linear correlation between COVID, between fever, between cough. So in other words, if there's more COVID, there's also more fever and cough. And that's logical because fever and cough are the main conditions faced.
Yeah.
I've also used a map chart to actually show the different number of cases in the US and India. So currently we can see that over here that New York is significantly has more COVID cases than California, which is down here. And then same thing for India. Uttar Pradesh is lighter, so it actually has less cases. And so this chart looks a little bit scarce because right now we only have 2 states per country. So for US, I only have done the data for 2 different states. However, once we have the data for all the states, all 50 states, then this map chart will look a lot more complete. Same thing for the India side. So when we have all the states, then it will look a lot nicer. And it will give us much more insights. Right now, only 2 states. So I'll go back into the presentation. So for my learning points, I think the first thing that I've learned, similar to Trinity, is that I've learned how healthcare data looks like because it's very hard for me previously to kind of understand or even to imagine how healthcare data looks like in the back end. Because we know, especially in Singapore, the healthcare system is generally quite solid. So we just assume that, okay, everything kind of just works. The data is there somewhere in the Singapore government server. And we just never really think about it, about how it's handled, about how analytics can be used to improve that. And I think this project has kind of shifted my idea of healthcare data, and I see it now more as like separate resources, much like in the fire server, that are sort of linked together. So we have conditions, we have encounters, medication, we have patients. There's so many resources that are being used in the server that I think really it has opened my eyes to how data can be used to transform the healthcare sector. And for more for soft skills, I have actually learned about project management and time management, because this is a much longer project than what I have done previously. And so I've learned to be able to work on different tasks, like bit by bit. So basically have to break down the big project into smaller tasks and to actually complete these smaller tasks on time. So I think this is something that I've learned from working on this project as well. Yeah, so do you have any questions? And I hope you enjoyed my presentation as well.
Very good, Nathan. So well done. Well done on that. And I think your insight, into that, when you start looking at health data, your kind of eyes begin to open up, that it's not magic how these health systems work. It does come down to exactly the kind of work that you've done, the insights that clinicians see. Again, they're not magicians. They do they use tools exactly like this to discover trends and figure out what's going on. And in the COVID era, there's all sorts of analysis now of the data. So in the UK, for example, there's a belief that maybe the lockdowns were maybe too severe and maybe shouldn't have happened. So all this data always gets analyzed in different ways. And so even experts, need to use these kind of tools to figure out what's going on. So you're beginning to see that, the value of these tools. So you've done a great job. So.
Yeah, a huge portion of public health training that some doctors go through is statistics. It's like doing a master's in statistics when they do public health.
That's right. So excellent, Nathan. So great job.
Yeah, thank you so much, Dr. Hana. And also thanks a lot, Mr. Akil, Mr. Kashyap, and Mr. Zor.
Thanks, Mr. Cake, for your comments, and thanks, Nathan, for your interesting project for COVID use case. So finally, we